Good morning. I'm not my usual chipper self because it's Sunday morning, so sorry if I'm a little downbeat. Welcome to Sunday of LayerOne. Thanks for being the people that didn't get shit-faced at the open bar last night. Yeah, so our first talk's coming up. Just some quick announcements. At 11 o'clock, so right after this, is Hebocon Robot Battles. So I guess in theory, if you're working on your robot in this room still, you have until 11 to finish it. If not, or after the talk, run over and make one real quick. But that's in hardware hacking at 11. Also, Soldering Olympics round 3 starts at noon. So if you're participating, you need to turn in your round 2 board. If you're interested, if you didn't want to compete, but you still want to take home the boards to play with at home, they are set up in hardware hacking. There are some learn to solder fun kits. If you are interested in getting some of the cards that I made, there's like 10-ish decks left, so hit me up in hardware if you're interested in that. Additionally, at noon today, there is a flock camera hacking competition in hardware hacking. So something, protect your privacy, something. I'm not good at the political outreach part of this job. But other than that, all the villages and contests are up. Some of the contests will close earlier than others. So if you're participating in any specific CTF, check with the organizers what time that they need to wrap up. Later today at 5 o'clock in this room is closing ceremonies, but all the other stuff is going on throughout the day. Coming up with our first talk of the day is pulverizing chips with the Squib and the Heatsink with Mehmet Sencan. Cheers, Mac. It's it. Awesome. All right, so it's great seeing you guys here in first thing in the morning, I guess, or maybe some of you are early raisers, I don't know. Anyway, so I'm Mehmet, and we're going to talk about how to pulverize chips with a heatsink and a squib in it, or whatever. Why would you, how, and so can you? By the end of this talk, I think you'll realize why would you ever want to destroy a chip other than frustration with the prices or whatever? How would you destroy a chip? And if you want to do it yourself, either with this approach or with any approach you want to develop, you have a roadmap, some idea about what it entails and how to develop these kind of products or something, or fun. Okay, first of all, why would you ever destroy a chip? Well, let's say you have your little factory and you're making little robots or GPUs, I don't know, servers, whatever, and they're secure, they're happy, they do their job, and then you put them on a truck, give it to a shipping company, we call this the supply chain, and then it gets to a customer, and the customer's happy, it does exactly what you said it would do, or if it doesn't, you fix it or something. Well, what if you don't trust your supply chain? What if someone just like offloads these from the trucks, and then takes keys out of them, and then like clones them or something, makes a counterfeit product, or puts a bug in them, hardware trojans, glitches them or something, and then your customer still thinks they have the product that you sold them, but no, it's actually a spy or something. Or another problem is the customer actually does get the product that you want, but they clone it. And they have a fake thing that attests to a state saying, hey, I'm here, I'm doing my job, but it turns out the customer's doing jailbreaking, doing something else, we had great talks on how to actually do that here. Or you are the customer and you actually received a good product. It's a good device, exactly as specified. And then someone just sneaks into your facility and turns it into a spy. You still are happy, but all your communications are someone else's. Or again, so you're the customer, or you have your thing, you have your secrets in there, and someone just takes them from you, and they have all your information. You don't want any of this. And how would that happen? How would somebody actually get into your chips? Well, we've had some really good examples recently. These are two different pieces of work. One is the famous Raspberry Pi hack. Raspberry Pi had anti-fuses. It's all the secret keys in there are difficult to image is what people thought. Well, iActive showed it's actually not that difficult to image. Someone can polish the surface and actually read exact bits and see what secret keys are in there in a supposedly secure chip. And this is another work by Shahin Tajik to the right. This is imaging an FPGA in runtime, so that even if the computations are encrypted on the way out, within it it's in plain text, and they can see individual transistors, and they can see them switch. So they can actually just read plain text computation. So trusted execution environments fail miserably if you have physical access. And TE fail is another one. They put interposers and read RAM. And this is the glitching circuit for Starlink. It turns out, your Starlink receivers, you can actually make them do things that are not intended to do. And I believe there was a glitching circuit last year and later on 2025 as well. I couldn't make it work. Oh well. So how do you get around these things? How do you get around someone with physical access to not be able to, modify your computers, your robots, what have you? Well, in your factory or in your point of inspection, if you're the customer securing these things, you inspect for any bugs, any implants or anything of the sort, and then you seal your robot. Well, by sealing, I mean you establish a secure perimeter. This could be a wire mesh. This could be a radio that just looks for impedance mismatch. This could be your power grid that you measure the impedance for. It's the motherboard itself. You put temperature sensors, impedance sensors, and other rocking sensors, light sensors. You put a battery, and you put these all within the secure perimeter. And if any of your sensors trip, or if the battery goes too low, you destroy the chip, so that no one can repurpose a chip and pretend it's something it's not. And how would you destroy? There are some options. You can do like blow up an EMP in there. I think FCC is going to have issues with that. You can use chemicals. Chemicals spill, and they're really, really slow. And hydrofluoric acid does not melt HF. And does not melt silicon. It melts silicon dioxide. There's a difference. You can use electric current. You can zap the chip, which is something I get all the time. Zapping destroys one circuit and takes a lot of energy, actually. And if you have an adversary who can, patch up integrated circuits, then zapping doesn't do much. You can zeroize. Zeroization itself does leak current information, but it's good enough for a lot of purposes, and it's we have circuits for it. It's easy. What else can you do though? Can you actually just shatter a chip? Pulverize it? Yes, you can. So the first thing I tried was nanothermite. I mean, this is about a year and a half ago. It turns out nanothermite is easy to make it by yourself if you have access to a clean room, or if you can just mix powders together. This is it's just aluminum and copper oxide. It's a black powder or black target. And you just put layer by layer, very small layers. And then you put them on a piece of silicon, and this is and then you put the current through it. And this is after firing. As you can tell, the needles actually are not touching the silicon chip. That's because the chip, actually we put current through the nanothermite. The nanothermite did ignite, and the energy of it actually melted the plastic underneath and propelled the chip inside the plastic. So it got lodged in there. So you can ignite nanothermite on silicon, which was a surprise for us because silicon actually is an excellent conductor of heat. Localizing an ignition there is actually difficult, but you could. The problem is you just propel the chip. The chip is intact. So I think you need some confinement. So we tried something else. I don't have the pictures here, but we put about a gram of nanothermite as opposed to, nanograms or whatever here. We put a whole gram of nanothermite on top of a P100 GPU. Also, these GPUs are P100s. They're $100 a pop. I'm not scalping. So this is a P100 GPU. We put a gram of nanothermite as thermal paste, which is a terrible idea. And we tried to get it to ignite. It turns out heatsinks sink heat. You can't ignite nanothermite with a heatsink on top. Obviously, we couldn't. So we cheated a little, put a little insulating material in between to see if it's even worth it. Well, some of you have seen, I guess, what it looks like when it ignites. Yeah. It doesn't take that long. It's just me dramatically reaching for the button. Oh, yeah. Fire. Yeah, no GPUs were harmed in this demonstration. It turns out single crystal silicon doesn't care if you light thermate on it. Yeah. So we blasted. We used that cord. Well, how do you... So like nanothermite, they couldn't work. So in terms of how can you, I guess is the question. I just looked around, I shopped around saying, how can I destroy chips? I looked at the zeroization and other methods again. I was like, oh, why don't we put explosives? They have more energy. They're small. They're easy to retrofit. Oh, easy to retrofit. I need to get back to it and saying, I think this can work if you can confine the nanothermite, and if you can if you don't have issues with heat sinks sucking your heat. So if you could put nanothermite in the motherboard traces, you can actually destroy a chip with this method, I think. It's exercise for the reader, you guys. And even then, honestly, nanothermite is doable, it's easy to get, but if you can't get your hands on just proper propellants, explosives, low or high, doesn't really matter. Low explosives, you need to confine yourself. If you can put them on traces yourself, just on the PCB, and then you have a good seal on top with the board, I think you can actually have self-destructing PCBs, and like you can destroy chips that way as well. We were looking more towards retrofittable solutions, so I didn't do, I'm not going to design a GPU motherboard again myself today. Maybe in a few years, but not today. So those are options for you. So retrofittable, we figured we can use a blasting cap or dead cord. And how do you get your hands on a blasting cap? But they don't sell them anymore, or just in construction stores to anyone. If you guys haven't watched Heat, anyway, it turns out you reach out to people who actually do explosives research. I reached out to 4 or 5 places. One is the Lawrence Livermore lab in up north. They didn't get back to me, even though they have an explosives research division. Maybe I need an introduction. I reached out to a range in Pennsylvania. They didn't get back. But our very own Arclight in ACCX Research, he's on Discord here. He got back to me saying, dude, just come Tuesday, we'll talk. And, I reached out Saturday. On Tuesday, we talked, and I think within a week, we were in a blasting range. This is a number 6. I'm just saying this so that you can do this too. It's local. It's the guy's on Discord. He's super chill. This is a number 6 blasting cap and a safety fuse. So this is a safety fuse. Is the kind of fuse where you walk, purposefully walk. You ignite one end of the fuse, and then you purposefully walk away. This is not as safe as like the electric fuses, but that's what they had. And yeah, no, nothing. The chip's fine. It turns out for these, especially these SXM GPUs, the mother was pretty thick, so the chip was just fine. So what we did is, instead of putting it sideways, we actually put it shooting up. In this picture, the detonator is pointing towards the GPU, like this. And yeah, the energy does go through, and the sand tamps it, so everything goes up. And yes, you can actually destroy GPU with a number 6 detonator. Big whoop. How am I going to contain that thing? I don't know, but we're getting somewhere. We actually destroyed the GPU. This is death cord with C2. Yeah, and this is how we sort of like made sure nothing flies away because, the first thing we tried, it just launched. So, yeah, I didn't put that picture here. We call that a product launch, but anyway. So this is what it looks like. In a few seconds, we'll have it go off. Yeah. If you didn't see that, I don't know. Oh, by the way, this is Area 53 in Barstow. It's available. You can do it yourself. I mean, you can reach out to them and, if you want to do a birthday party or something, they do that too. But yes, it goes off. And it's kind of an overkill. C2 and dead cord is kind of an overkill. I can't contain this. The whole point of this thing is that I can put these in server racks and that people can hold on to them by their hands, and then they won't, if it accidentally goes off, they won't break their hands or something. We want digital security. This doesn't do that. So we did a number 8 blasting cap directly on top of the heatsink, taped it up, destroyed the heatsink. The chip's fine. It turns out there's a big plate of copper, and then there is a bit of a heat spreader in between, and those just reflect the blast. We just want direct contact. So this is us drilling into that heat spreader so that you can get direct contact to the copper cold plate. Yep, that worked. We shot through the cold plate and destroyed the chip. But it was too much destruction. But we got something. We can destroy chips. We're happy. We go back home. And we tried thermite again. It didn't work. Oh well. Oh, and at the end of the day, by the way, this is how you properly dispose of explosives. Is that you check them out from a magazine. Magazine is where you store your explosives and you write them down. And then people just don't log them back in, typically, it seems. And if you want to, and you can't hold on to one of these for longer than 24 hours, so you put them within a gallon of ANFO, which is, I learned, ammonium nitrite fuel oil. And you put all your detonators in there and you just set it off. Of course, you walk away, and then it just gives a little shock wave that you can feel from like 100, 200 meters away. It's fun. Yeah. So that was that day. We got stuff that's too strong, didn't do the job. So we just looked online. ArcLight looked online for me mostly. I found this thing. It's a Lone Star oil fuel detonator. It has some nicer properties. One, it's smaller. Two, it has lead azide and RDX, which are more stable than your typical detonator stuff, like Petson or something. And we did test this for temperature stability for equivalent of 5 years, I think, continuous use in 95 Celsius. We did that by 125 Celsius for 35 days or something. It's all written up somewhere. I should publish it. So we use these. And I put these detonators on the backside, and I had these like the laser cut steel plates made so that you can, contain the blast. Nope, you can't. And the chip's unusable. It's cracked, but it's not pulverized. You can still reverse engineer this baby. So yeah, I just left an impression on the copper. That's all. Backside doesn't work. Front side does work. Oh, sorry. I should have said this slower. Front side may work, but turns out it does. You put a detonator on the front side of GPU. This is this is a non-working V something. This is normally $500, but if we put these detonators on the front side and made a little indent on the heatsink, we did the same thing with the SXM GPUs, the server ones. Put them, close them up, put them side by side. Will it destroy? It turns out it will. The chips are destroyed, as you can tell, but so is everything around it. We need to go smaller, much, much smaller. But you can destroy chips, which everyone knew. But yeah, if you need to know, if you put a detonator right next to the chip, it destroys the chip. It does detonate. Anyway, too much damage. We use sand to temp it. Nah, still too much damage. We use dual cell, which is this aerospace thing it's a sponge, metal sponge, and then we put a Kevlar sock around it, knitted Kevlar, not woven, so it's flexible. Yes, you can contain the damage. You know, damage gets contained within this Kevlar, but it's still too much of a boom. It really is. We don't want this. We want something smaller. So, and at this point, it's about a year. I give this talk in places, and people keep telling me, "Why don't you use a squib? Why don't you use a squib?" And I'm like, "That's weak." It's like, what is squib? As you all know, squib originally is an offspring of two wizards, a wizard and a witch, who is not a wizard or a witch themselves. That's a squib. And in the long tradition of giving muggles just energetic and fun stuff, like Alfred Nobel and people before them, they have given us something called black powder with wrapped in paper, and they call that a squib. And in this Muggle world, what we call squibs is what we use in Hollywood or other places where you want to propel something. It's the thing they use for bullet hits. When you shoot someone, blood goes off. That's a little bit of explosion. And in order to find that guy, in order to find squibs, the easiest way is to call up a special effects guy in Hollywood. This finger is that of Frank Siegler, and I got through him through SFX Unlimited in Burbank. LA is great for this kind of work. And that's a 1/8 squib. Doesn't do much damage, but we did a microdet, which is a little bigger, and that does do damage. And there's a video of what kind of outside report we see on the microdet. So yeah, it's a few seconds. It's a microdetonator in an SXM. It's an H100, like a server H100 in the middle. This flicker is 60 hertz, your power line flicker on the fluorescent lights. So that, and yeah, it's a little whoop, not too big. And it does destroy chips, not as completely as we like, but it does work. If you put it smack in the middle, as you see on the right, the chip's center is destroyed. But these microdets I don't think they're that stable. They're not meant for aerospace type of stuff. They're mostly meant, or like high temperature stuff. They're more for keeping Hollywood divas safe, But they work. And this is on SXM. But we were thinking something that works in high temperatures over time reliably, aerospace things. And I reached out to many suppliers. I sent them emails. Most of them didn't get back to me. It turns out they all work for people in Gundo or other places. But this one guy did, from Texas. He's like, "Oh, you're destroying GPUs. It's great." Rami really just gave me a pyrotechnic initiator. This is something that's called ZPP, and that's used by NASA, and it's the standard initiator that they have. It's mostly for pressure and not the shock value, or not the explosive value, but it sort of does the job if you put it right next to the GPU. If you put it a little bit away like this, it doesn't do much. But if you make a divot on the heatsink right to the edge of the GPU die, and we're not smack on top of the GPU die because we still want to be able to cool the GPU, we get something. We do get something. Okay, yeah. This is us putting together that pyrotechnic initiator on the GPU. Those are sandbags. And you're gonna see a smaller report than before. That's the idea. In a minute. And as I said, this is ArcLight. This guy helping me. It's ACCX research. It's really chill. I was on Discord. You should Discord him right now. Yeah, I saw your stuff, dude. All right, we're still waiting. This is mostly me waiting for the oscilloscope. Oh, yo, if you're gonna set up an oscilloscope, I should tell you how you do it in a second, though. yeah. 3, 2, 1. No, 3, 2, 1. 3, 2, 1. Yeah, right there. No, what? Oh, wait. The report is there. We couldn't see it. Oh, yeah. Okay. It's a very little report. It only takes 5 microseconds. 50 microseconds. It's not barely observable from the outside. And the way you measure this is you put a high power resistor in series, and then you put the oscilloscope in trigger mode, edge mode, and like single sweep. And you charge your initiator before you hit trigger, because the charging sends a little current, which then your single sweep picks up. You don't want that. And then when you run your scope and then hit detonate, this is the kind of trace you see. So within 50 microseconds, what I believe happens is you get the initial current, and then it blows up, and then you have some residual, plasma there that sort of conducts electricity, and then it levels off, is what I think has happened. So this is the aftermath. Nothing really happened. There's a little bulge. This is normally flat, but you can destroy a GPU. You can pulverize. And I think with pyrotechnic initiators, you can destroy GPUs. We might need to play with placing and such. And it's these are things that are shippable on passenger airplanes. They're really safe. They are using airbags and pyrotechnic fuses and what have you. Yeah, I'll get there in a second. Which is so far we talked about why you would destroy a chip and how you would destroy a chip, and why was more about preserving integrity of your GPUs or any robots. If you're selling someone a robot, you want to make sure that remains a kitchen robot and not a destructural robot or something. I think reverse engineering robots, I think James Cameron has a movie about that in the 80s. You don't want that to happen if you're the one sending it. How I think pyrotechnics or detonators, they do work. You just need to be small. Like this is what we ended up happening is like 30 milligrams of ZPP. What we started with was 400 milligrams of RDX. It's just go small, and it works. And so can you is the part is that we'll talk about how would you get your own hands on it, and how would you actually do this work in your field. There are two ways. One is you let someone else do it and go through the paperwork so that you don't have to do any paperwork, which I'll get to in a second, or you do the paperwork for yourself, and then you become a person who can deal with explosives or pyrotechnics or what have you. There are 3 main bodies you need to be careful about. One is Department of Transportation, one is the ATF, or BATFI, I guess, and one is your local fire department. And we'll get to them in a sec. So with the Department of Transport, they regulate the transportations of energetic materials. And by default, you can't. You need to get a classification of your energetic material saying, this device is this much energetic material. It's going to be stored, packaged in this configuration, and the Department of Transport tells you whether you can put this on a truck, whether you can put this on an airplane, what certifications does the driver or will need to have, and so forth. And the pyrotechnic initiators we talked about, if they're packaged properly, you can actually just ship them on your passenger aircraft. They're really fine. The detonators that we talked about, you can't. And also there are things about what kind of thing, if there's a chemical hazardous thing in a truck, you don't want a detonator right next to it, right, in case something goes wrong. That sort of thing is what they regulate. They regulate transport. So you get classifications for that. ATF regulates two main things. They regulate commercial use of explosives. That's a fine distinction. And they regulate storage of any explosives. So if you're making your own tannerite or something, ATF doesn't really care, as far as I can tell. If you buy one thing that is not an explosive and another thing that is not an explosive, put them together and use that the same day for your own use, ATF doesn't mind. That's how people, have fun with tannerite. They put A, B together and then they shoot at it. It goes off. It's fun. If you're going to either purchase explosives, things that are explosive, or energetic propellants, what have you, or you're going to manufacture them yourself for commercial use, and YouTube counts as commercial use, or if you're going to store any of this, you're not going to use it within the same day, then you need an ATF license. It's called an ATF Federal Explosive License. It's a 2-page form. It's not that bad. Like on the explosive side, it's easy. It turns out the industry, the explosive industry, self-regulates quite a bit, which is why I told you people don't, answer my phone calls. But those who do actually care and actually want to help. And since the industry self-regulates, ATF doesn't feel the need to regulate as much. You fill the form, and then they come to your office. At a time, like within a week or two. And then they talk to you, make sure you're safe, you know the regulations, you know how to fill up the forms, and they give you ATF, they give the federal explosives book, it's called information manual, whatever. And as soon as you're safe, you're saying you're fine, you can buy explosives, you have a license for it. You just have to log everything, and you gotta keep your explosives in a magazine, which we'll get to in a second. Local fire departments vary wildly. Some are crazy, some are chill. Which is why you sort of gotta ask around. So that's ATF FEL license. A word about magazines. So ATF wants you to store any energetic material in a proper container, which is usually called a magazine, which is a room, a trailer, that sort of thing. And their main worries are twofold. One is they want something that has two locks, that has access control, so that no one can, get inside these things and do nefarious things with them. The other thing they worry about is people shoot at things just for fun, and if anyone shoots at your magazine, it doesn't go off. So the construction requirements for these magazines are basically made so that it would stop, I think, a rifle round. It's steel and a wood inside, so that if anything penetrates through, it won't be hot by then and it won't set off your explosives. That's really what ATF cares about: storage, and nefarious parties don't get their hands on it. I just told you can get an FEL license easily. If you don't have a magazine, how are you going to get a license? It turns out they have a solution for that. You just go to an FEL licensee who has their own magazine, and you get a letter from them saying, any explosive that you're not going to use within a day, you're authorized to use their own magazines, so that you will store them there. And and the ATF gives you a license with that. So what I see a lot of people on YouTube do is they get that, they have someone who's willing to actually let them use their magazines, but they don't even do that. They just make their explosive materials that day in their home, which is an ATF inspectable site at that point, and then they blow it up the same day. They don't worry about transport. So the other thing I was going to tell you is DOT classification and ATF special explosive device exemptions. So it turns out explosives are everywhere. Energetic materials are everywhere. If you've driven here, your car has airbags. If you've flown here, there is about 100 pyrotechnic initiators on your aircraft in case the hydraulic fails. Those flaps can jam open. And there's fire suppression systems. All these things are everywhere. They're safe. you don't need a license for them. And this, for instance, is an explosive circuit breaker. What it is a piece of pyrotechnic charge inside. And this over here is the same thing. It's different form factor. And you have your power bus bar, which is which carries high current. This is used for solar installations, even at your homes, or in all electric vehicles. And if there's an issue and the current needs to be cut, you can't just flip a circuit breaker. It's a lot of current. You have, excuse me, you have a piston that is driven by a pyrotechnic initiator that breaks this bus bar, this current thing. And this is something you can just buy on Amazon. You don't need a license for it. What happened is somebody actually filed a DOT classification saying this is something you should be able to package in this thing. Like this counts as the packaging. And if you pack these together and they're all in a big bag, if one of them detonates, the others won't detonate. There's no sympathetic detonation is what they call them. Seriously, sympathetic detonation is the name. And if an ATF cares that you get that DOT classification and that it's actually not that easy to open. That's all they care about. I can take this apart, then it will be contraband, but it's not that easy. That's what the ATF cares about. And it's also, there isn't much in this. So those are, if you get those exemptions, then you can make a product that you can sell to anybody. If you don't get those exemptions and you only have your AFIA license, then you can make products. And you can sell that to any government agency within the country, states, federal, doesn't matter. The military is its own thing. ATF doesn't regulate that. If you're a contractor, you don't need me to talk to you. But you're not regulated by ATF at all. And so you can make things for your own use, and you can sell to other AFIA licensees, people who either do pyrotechnics or who do mining or what have you. If you do get a DOT classification and an ATF special explosive device exemption for your device, then you can sell for its intended use to people who do not have a license. And this is what I tend to do for GPUs, or, integrated circuit breakers, I call them. Integrated circuit breakers, breaking integrated circuits. And that's, it's a process. We're learning our way around it. But hopefully, within a year, you can buy sealed GPUs if you get through it, or things that you can't, that are tamper-proof GPUs, tamper-proof hard drives. And if you try to tamper with them, the chip is broken, so you don't have to worry about like a BitLocker backdoor or whatever. Or if I did a good job in my talk and you reach out to people, you can make your own thing. I don't think it should take more than a year to actually make your own thing, and at least in small quantities. And yeah, it was great. And feel free to reach out to me. My signal's over there, Mehmet.72. Go hams, thank you. My email is mehmet@airandle.ai. On the Discord, I am with my first name, Mehmet, and Arclight, who helped me, is Arclight. So you can reach out to him as well. Sort of on time. Also, I'll be around. Well, apparently I can take questions since we do have time. So if